Welcome to LOS 713 for week 7. In this particular week, we will look at descriptive statistics. Now, the chapter has a lot of information in there, and hopefully this video will show you exactly what you need to know and how to manipulate around certain functions and equations that you don't have to spend your time solving with a calculator, paper, and pencil. That was the Ice Age. We have a lot of tools that we can use to do all that work for us. The important thing out of this is that you are able to analyze your results and your data, and that you can make informed decisions about it. So this will show you different ways to find these descriptive statistics, either using the internet, either using apps from the internet, or Excel, or Google Sheets. Do not go out and buy a new calculator. And this will also give you the information that you'll need to understand so that when you get to the SPSS portion of your studies, then you won't have to spend a lot of time thinking on what these actually mean, but you can let SPSS do all the work for you. So we're going to start talking about displaying the data that you have from your surveys. So let's go back to the textbook here. And as you can see, it's descriptive. So there's a lot of information that I'm just going to go over. But the first thing that I'm going to look at is displaying your data in a stem and leaf plot. And the best way to think about this is that when you have some data, you usually can put it into the stem, which is the first number or first set of numbers, and the leaf is all of the other numbers part of that. So what do I mean? Well, out of all of this data that we have up here, we have starting with 33 all the way to 100. What the stem is that 3, 4, 5, 6 all the way to 10. This is read 33, 42, 49, and 49. So there are two 49s. There's a 53, there's a 55, and a 55. 61, 63, and so on. And that's 100, 10, and a 0. That's how it's read. And if you can imagine that you take the stem and you turn it 90 degrees, it can look like a bar graph or even a graph. And sometimes this may look like a normal curve, which we'll talk about later. But it looks like that if you could turn it on its side with this stem here as the bottom, like consider it the x-axis and the leaf as the y. So it sort of gives you a picture of what your data can look like. And this is used in a lot of examples, and one fairly popular example in a lot of statistical course is the ages of the presidents when they were inaugurated, and they put that in a stem and leaf plot. And there's something, and so you can do that as an example. And so I then taken this particular example here, example 2.4, and 40 mothers were asked how many times per week a teenager must be reminded to do his or her chores. So from 0 to 5 is the number, and the frequency is 2, there's 14, and so on. Put this in the stem and leaf plot. So I have the stem and leaf plot here, and so I'm sorry, I put it in the graph over here, and I'm going to talk about that in a second. So that's one of the things that you can do is make another type of plot. So I'm going to show you how to make a stem and leaf plot with more than just those numbers. So I just have these numbers here. They don't mean anything here. And this is a stem and leaf plot generator. It's from, just go on the internet and type in that search, and you'll get many, and this just happens to be one of them. So I want the leaf to be 1 digit long, and the stem goes over here. So I calculate, and I've already done that. So you can see that it looks like this. And what's cool about this particular site is that it gives you the maximum number, the minimum number, and the range, the count. It also gives you the mean, the median, and the mode. And the mean is the arithmetic mean out of all of these numbers. So whatever this represents, this data set represents, the mean is 73.52. The median is the number in the middle, that's 73. We'll talk more about that in a few minutes. The mode, 94, that means the number that appears the most. Standard deviation is 17.92. We'll talk about that later. So keep that in mind here when you're looking for these other types of statistics with your data. So that's one way of representing your data, is with a stem and leaf plot. So again, don't have to do it by hand. You can just find a generator online. That's one of the easier ways to do that. So going back to this section here, we have a histogram, and we'll talk about the histogram. So this is that it's a number of times teenagers reminded in frequency, and you can make a histogram out of that. It's not very interesting at all, but I'm going to use something else. I have this sheet over here with a lot of data, and that sheet comes from this particular one. Downloaded this from some free website, and it's just a bunch of data, order date, and item, and a unit cost. So what a histogram is, going back to this particular chapter, is that it's another physical way to, it's like a bar graph, but it's connected. So there's continuity, there's continuous data here, rather than bar graph, it's discrete. So you can combine them. You can do it in different ways. Here, this is the number of students playing video games. And because we're talking about time, the time out hours here, so that's from 0 to 5 and 5 to 10. So it's continuous, it's not blocks. So you can make histograms very easily. I will start with Excel for this particular one, and I'm going to make a histogram from the order date, and I'm going to make it with the units of these different types of things they bought at the office. Okay, at the order date and what they did, pencil binders, pen sets, and so on. So I'm going to highlight. So if you're on Excel, you highlight this particular column, and I hold my control button down if I'm using a PC, and then I will now insert a chart and a recommended chart. So there's different types of charts. I'll just look at what they offer here. That's a line chart, and that's a time chart. That's going to be something that can be shown as well. So you can do that and say OK. So I can say OK on that, and that's one of the line charts there. And without messing it up too much, you can just move it over a little bit. It's going to be very important when you do your writing and your research and you put these in your results, whatever type of charts you use, all charts, that you have the right title and you have your units also explained and labeled on each of the axes, so that we're not just guessing what this is. So I'm going to do another one with the same two here, and I'm going to make a histogram. So I'm going to insert, again, I want to go back. This is my way of doing it. So this is the recommended chart, and let's see, we have a bar. This is a bar chart here, and so let's see what this is. This is a histogram. And the thing with this histogram is that it put it in units. So it's not the best looking one here. So you can say that, well, probably this data doesn't fit a histogram. So that's something that you can play around with and say that one is connected there. And you'd have to make sense out of these things, and also probably you can change that. That's something you can do in the edit here. So that's a different way of looking at your charts. Now I'm going to go to the Google Sheet and look at these two particular charts. So I'm going to highlight, hold down the control button, or you can just spread your cursor over both columns. Insert a chart. So I'm just going to insert the chart here, and it gives me this time chart, line chart here, and you can see the dates and number of units. So it's much more clear right here, and it does, even as the title has some semblance of meaning here. Now you can also, I'm going to get rid of this chart editor, and I'm going to do it again to see if I can get a histogram. So I'm going to insert a chart, and it's going to probably give me another chart here. There we go. And I'm going to bring this down here so I can play with it over there. And then you go to the chart editor, and it's the chart type, line chart, and you can go down and you can make as many different types of charts. And at the bottom here is a histogram chart, and there's your histogram. See, it's continuous data and so on. Now, you'd have to fix these dates. It doesn't know how to read these dates here, so you'd have to probably fix that as well. But it's just to show you that there's continuity, and that's one way of showing your data. And that's what we're trying to do. So there's a time chart here and an histogram there, and we have the stem and leaf plot. And that is what we're looking at in this section here on time to display your data. Then we have the measures of the location of the data, quartiles. So quartiles are exactly what you would expect, and it's another way to show the spread of your data, and it's leading to something else. There's a timeline there. So I'm going to go down to quartiles, and you have a lot of examples to try. The biggest pain out of this, everybody, is to input these data here. And that's why I went online to look for some free data to just download and so I can play with it. So this is location of the data in quartiles. So there's a lot of things here about percentages and so on. I don't want you to get hung up on the percentiles yet, because percentiles are going to be much easier when we get to normal curves. So let's just show you what quartiles is. And basically the quartiles, if I get through all of this stuff here, is this particular looking thing here, the box plot. And what's the box plot? Well, I'm going to take the data that I had in here and copy it, and I'm going to put it here, and that will help to show you what a box plot is. And that's the box plot. You might have seen that. Okay, it's a box here, and that tells us that we had 31 people. That's our n if we were doing the size of our sample. The median is the number in the middle, and that's this line here, 73. Okay, and then the first quartile is 61. So it goes from bottom of a number is 33, and 61 is, that means 25% of the people are in this range. Okay, that's the first quartile. And then the third quartile is at 90. It goes here, okay. And so that's the second quartile would be 50%, and interquartile range 29. And you can see that there's a lot of information here as well. And I want you to keep this in mind. This mean, geometric mean, median, mode, and standard deviation, those types of statistics are going to be important as we go on in this particular section of the book. So that's something to keep in mind, that this site will also give you more information besides going on Google Sheets and also on Excel. So I'm going to take what I did and I'm going to make quartile calculator. This is another way of doing it. I'm just going to paste my data here and calculate, and it just tells us what all of the things are. First quartile goes up to 61, 61 to 73 is the second quartile, 73 to 90 is the third quartile, and then as we have the median is 73, the number in the middle, and so on. So you have this statistic without looking at the box here. So that gives you also information at what you can find. So that's what the quartile is, and that's another way of showing your data, as we find that where the location of your data is and does it make sense. Again, let the internet and these apps on the internet do the work for you so that you can interpret what it means. And then it'll even explain it here on the right to give you a little bit more. So that's a much better way than doing it by hand. So we go on to the next section. That's the center of the data. This is arithmetic mean, geometric mean, median, and mode that we're going to look at here. So I'm just going back to the book here in the next section. Again, there's sections on percentile, finding a percentile for the value in a data set. Don't worry about that. We don't need to worry about that now. Okay, so just want to get to the ways to see how close your data are into the center, and does it make sense. So there's a lot of information there. So the first thing we'll look at is arithmetic mean, and that's a very basic thing to do. So I'm going to move these out of the way here by deleting them. They're in my way. Delete that, and they're in my way. So get out of that. So this is Google Sheets. So I want to find the arithmetic mean. That means this is how you find a formula or to do math with this mean. So we have these set of data here, units sold, and I want to find the mean net. So you select the box and you put the equal sign in there, and that tells Google that you are ready to write a formula. So in Google, it's average. Okay, so they have the average here, and numerical average in the data set, ignoring text. Okay, so now it has this open parentheses, and it's weighting, it's suggesting, are you talking about B2 to B54? And I am, and that tells me that answer. But just to be clear, I'm going to highlight the numbers that I want to find the average of, and go down all the way to the bottom, and then just press enter, and it sort of hides it sometimes. Here it is, 49. And so if you were doing this, you might want to put averages, arithmetic. All I do is add up all the numbers and divide by the number that you have. That's arithmetic mean, the average. And in Excel, we have, let's say this particular one here, and I'll move this out so we can say it, and I will find the average. So this one, again, you put an equal sign. Now it triggers this function line. That's where you can write down the actual average, and you find that of all the cells. These are cells, of course, and or you can just find that particular one. You can see these are the ones that I've done before. So that's the average, and it's asking you what series of numbers you want to find the average of. So there's this little blue and red dot here, and it just tells you that I want to find, I'm going to take the average of the units here. So I go down until I get to the bottom, and then I click this again. Now it has this series in here. I hope that's correct. And 49.2 is the number that I have. So 49 is the average, 49.3 I should say is the average of these units. That's what the average of all of these are. So that's arithmetic average. Now, in statistics, depending on what area your study is, if you study especially economics, there's something called geometric mean. And geometric mean is taking all of the numbers and multiplying them by themselves, by all the numbers and multiplying them, and then you take the n root. So if you had 50 numbers, you would multiply all 50 numbers, and then you take the 50th root of that. So this is where you can't do this by hand. So you'd have to do it with a calculator. But again, we have ways to do it on Excel and on Google Sheets. And what it means is that what we're trying to find, and it's in economics, and I'm not an economics professor, so I do not have the knowledge of how to use this. The book explains it. If it's in an area that you will be studying, then by all means take a look at it. But it's just something to give you an idea of what would be the best number to give you all of the sides of this cube. So what it means is we'll go back to our Google sheet here, put the equal sign, and I'm going to put GO mean, and that's what we're looking for. So I'm going to find the GO mean of these units. So again, I'll just go down, highlight them, and finish. I press enter, it automatically goes in there, and I have to do a little search because mine is 34.9, 35. So 35, that would mean each of these sides is 35 in order to get that cube. So that's what that means. And so there's an economics connection in the text that I'm not going to get into. And it's in Excel, you do the same thing. I'm going to put an equal sign in this one. This is going to be a geometric. Now I'm going to write geometric mean so you can get the difference here. And that way, and then I'll put, actually I'll put an equal sign right here. And if I can get it there, and I put an equal sign is, all right, now that equal sign is waiting for, it's not going to work here. I'll just leave it alone. Put geometric mean in the box there. Now I put an equal sign there, and I'm looking for geometric mean, and since I already did the geo mean, same thing. Press this little red button on the radio button, and I want the geometric mean of these units. So I'm just going to highlight all of the units till I get to the bottom. That's what I want. That's okay. And that's my geometric mean. Now, this is a bit of a difference in the algorithm, so you'll have to look at why it's different here. These numbers may not all be the same as the one on the Google Sheets, but that's the process of finding the geometric mean. And so again, geometric mean, this is the formula, and this is what we're doing. We're trying to find the size of this cube. That's basically what the object of the game is. So if we scroll down, you'll see that we have a geometric mean formula down at the bottom. And by the way, this sigma, you don't have to really look at this section. Sigma is just a capital Greek letter and it means the sum of. When you take the mean of something, all you do is you add up the first number to the last number, and then you divide. This is multiplied by 1 over n, so divide by the number that you have. So what you've been doing with average or mean since you were in the 4th grade, that's what this formula represents. And the mu, this Greek letter mu, represents the population mean. X bar means the sample mean, something we'll get into later on. And again, SPSS will do all this work for you. So you can see the geometric mean here, and you have the pi values. That means we're multiplying all of these numbers and taking the n root of that product. So, and then going back to this is the median and the mode. Okay, so we go back to finding the median. The median is the number in the middle. So if you remember from this quartile here, the median was given. So we know that 73 is the number in the middle. And even in the box plot, when we did this, if we wanted to find the mean, okay, of that, all we have to do is press that, and it gives it to you right there. So that's the mean of all those numbers. So you didn't have to go to Excel or to Google Sheets. The geometric mean is here. And then the median, that's the number in the middle of your whole set. Press that, and it's 73. And the number that appears the most is called the mode. Certain times you want the mode, that's 94. The mode is sometimes difficult to understand. Why do we need the mode? The mode can be something that, let's say you're shopping for shoe sizes, and you'll shop them for the most people, the size that fits the most people. That would be the mode. You just want that number to appear the most. It's a really simple and probably dumb example here. And to find the median and mode, again, let's start with Excel this time. So this time I'm just going to write down median and I put the equal sign next to it. And I'm going to, there's the function bar. Do I have a median? There's a median right there. And it's saying, where's the data that you're looking from? I'm going to find the median of all these costs here of how much I spent just for the fun of it. And do that. It's okay. And my median of those numbers is 899. That's the number in the middle, is an 899 right there. Okay, so that's the median there. And if I wanted to find the mode, the number that appears the most, if there's a number that appears the most, I'll just write equals. And let's say if I have the mode, do I have a mode? No, so I have to go to more functions. And I can just type here mode. I can get the mode to show up. And there it is. So, and it's asking me the mode of what? I'm going to stay with the units here because that might give me a better number. So I don't have all the numbers here. That's why it doesn't look, it looks weird. Somehow I lost some numbers here. So I'll just use what I have. And that's fine. And that's the process here. On Google Sheets, let's say I want the mode. So I'll just move it over. I start with an equal sign and I'll type in mode and what are my values. It's going to be different here because I have a different set of data here. I have all of them. They disappeared on the Excel sheet. And enter, and again It's a big secret as to where they go. So the mode is 50. And then if I want the median, and I press the equal sign, and I start typing median, and it comes up. Again, what's my data set? Go down and enter. And let's go up and find it. And it's 53. So that's the number in the middle out of these data here. So that's what we're looking for. That's what we're looking for. Is one way to do it here, and there's another way to do it here, and there's a way to do it here, and there's a way to do it here. Not there, here. Okay, so what you're doing is finding the middle number, and that's going to be important in certain types of quantitative research papers. So it's up to you as to what you're going to be doing with that. Now, a great way to help you in determining whether your data are close to each other is how far they are spread out. And the main way to do this is by standard deviation. Now, the formula to find the standard deviation is this one. Back in the Ice Age, that's when you used the calculator, and what you did is took all the numbers, you squared their differences, and then you divided by n minus 1, the number of data that you have minus 1. And that leads to a normal distribution curve, which is where you can get percentiles. Much easier getting it from here. So that's the equation. So of course, we're not going to find that with the old-fashioned way. So if you look at our box plot, and we saw the standard deviation here, the standard deviation is 17.6. So this is where analysis comes in. So it's 17.6 out of all of this data. So you have to decide how close these data are to the mean. That's where this gets five. So 17 means 17.6 is about the standard deviation from the mean, and the mean was the mean was, it didn't tell us. So let's go find the mean again. 17.6 away from 73.5. So my personal preference in finding in making a decision here would be that that's a pretty wide area of differences and deviation from the mean. It's not that great. If this was a test and the mean of the test was 73, these were test grades of some kind, then that would mean that you got 17 grades both on both sides here, and that's not very good. A standard deviation of that's very small means that your numbers are close. And that's what you really want to show, that your mean actually stands for something. When your mean is just a number that's very far apart from all of the data that you have, then it's probably not the best number to use. And I'll explain that in an example in a second here. So that's what standard deviation means, and you probably know that already, but we're going to look at how to find standard deviation here. So I'm just going to put down SD just for standard deviation, put an equal sign here, and so I'm going to write down standard, and let's see if it writes down ST standard deviation, and you have okay, now you have entire population of a sample, standard deviation. This is the best one to use so far, so we're going to highlight our standard deviation for here, and press enter, and our standard deviation for these numbers is 30. Now that's pretty wide, okay, especially when our average, which is 34, I believe was 34, might have been that, is pretty wide. So that's something that you'd have to watch out for. In Excel, find a standard deviation. I'm going to put equal sign, and let's say the standard deviation of the total number, just for the heck of it. So it's looking for a standard deviation. I might have used it earlier. There it is. So now it's asking me what numbers do I want, and I'll say, how about the total numbers, just the standard deviation there of these. And again, some of the data has disappeared for some reason, and I'm going to press OK, And the standard deviation of these, because we have 1,000, 1,000, and I'm just going to find the average or the mean of these numbers just to make a decision. And let's see if I can find it. So they call it average here, and I want to find the average of these numbers. And that's what I want. And when I get the average, 499 with a standard deviation of 488 is not very good. So that's something that you would want to avoid. Now, in the text, they have this mean, median, mode with the histograms and measure the spread of data. Standard deviation is given here. This is what we had here. I want to go back to the reason for the skewness and median mode here in an example. Sometimes it is where the question is, when is it best to use the median rather than the mean? And this would be an example of when you have a person, let's say you live in an area in your neighborhood where the average price of houses is $500,000. And there's a person who down the corner has built a $2 million house. If you take the average of all of the property values of those houses, it'd be pretty high. But if you took the mean, then it would be more normal than looking at what the average is. That's an example of being skewed. That one person, that outlier can skew your average and move it over to a number that's not acceptable. But if you put your numbers in order and find the number in the middle, which is the median, then that's a better indicator of the center of your data. That's what that means about skewness there. So the conclusion to this is that you don't have to spend hours with a calculator to determine your results from your raw data. And use the available apps on the internet that we've used. There are many more. And you can also look at YouTube for some ways to find these answers as well. Google Sheets and Excel are also sources. You don't have to buy anything, so you don't have to buy Excel. Google Sheets is available for free. And just to let you know that if you continue in your statistical research, and especially for your dissertation, that we'll be looking at SPSS software as the main software to find all of our results from our data. So that's the end of our presentation. And again, I hope you have a great week and take care.